I have a normal distribution. The mean is 40 and the standard deviation is 10. Use R to find a value x0 such that 70% of something have a width larger. That probability is given, it's 0.7. We use the formula z equal x minus mu over sigma. You want the value of x0 such that the probability that x is bigger than x0 equals 0.7. It says bigger, and remember the z table gives you the probability of being less, right?
Yeah.
The chance that x is smaller than x0 is 1 minus 0.7, which is 0.3. It has to be less. You write q norm. This one is equal to 0.3. You put the probability 0.3 here, you put the mean and the variance.
How do you know if it's Q norm or P norm?
Yes. So now I would use P norm if the value of x0 is given. So let's say the probability that x is less than 35, then you have to put 35 here, the mean and the standard deviation. You see the difference?
Yeah.
He's giving you the probability. He's hiding the probability, but he's giving you the value. You will use the P norm when the probability is not given. You use the Q norm when the probability is given. Add that to your cheat sheet, and I think you'll be fine.
All right.
Probability that x is less than x0 equal, we know it's 0.3. We have the mean, right?
Yeah.
And we have the standard deviation. You have to change this into z, and you do x0 minus the mean over the standard deviation, and this is equal to 0.3. You go to your z table and you search for the value of z. What is the value of z such that the probability will give you a 0.3? You can take the closest value. Maybe this?
Yeah. Yeah.
So how much is z? Minus 1.88. Does it make sense?
When you plug the number into the package, do you take the negative? Do you?
Yes. So just to be clear, I do 1.8 plus 0.08 is 1.88, and you just add the sign.
No, I mean, okay, so take the number and put it on the brackets on the equation you made.
So you mean here?
Yeah.
Yeah. So you have x0 minus the mean is 40, the standard deviation is 10. So minus 40 over 10, and this has to be equal to minus 1.88. 10 plus 40. So what's the value of x0? 21.2.
Is there a situation where you don't take the negative? Because on there was a question we did on the session when we use alpha and then subtract and divide, we didn't take the negative. I don't know if this is a mistake or.
On the right, I have to do 1 minus, right? So that's a different thing.
No, I mean, do you have your phone on you?
What's that?
Do you have your phone on you?
Yeah.
I sent you the picture of this question.
Okay. So says let x be the height of the student. Find it. Oh, so that's confidence interval.
It
Yeah,
was
we got 1.96. So what's the issue?
it was negative 1.96.
Mm-hmm.
So do we take the negative or no?
Ah, good question. So this is a digression on confidence interval. Look at the formula for the confidence interval. It says x bar plus minus z and this, right?
Yeah.
When you use alpha equals 0.05 or 95% confidence and you divide by 2, you get z equal minus 1.96. Now let's say you plug minus 1.96 here. What happened to the plus minus? What is plus minus?
Oh, so the plus will change to minus and the minus will change to plus.
It doesn't change anything.
Okay.
Okay, so you said you did question 5, which is confidence interval for the mean. Did you use the z or the t table? Look at the sample. It's large. 64, bigger than 30, right?
Yes.
And you don't have the population standard deviation, you have the sample standard deviation.
I used Z table, I think, yeah.
So I don't think you have an issue with this unless you do. Z for 95%, Z is minus 1.96, but then plus minus is the same thing. Here's your interval. In math, when you say interval, it's an interval. It has to be AB. So A is 2.85 minus 0.8575, and B is 2.85 plus 0.8575. This value is x bar, and this value is called the margin of error. So the interval x bar plus minus the margin of error. The confidence interval is given as an interval, not just as a plus minus.
Yeah, and we use brackets, I think, yeah.
Exactly. So the lower bound is A, the upper bound is B.
Well, on the next question, he did use different confidence interval.
Ah, you see? This one was the t-table, only because we have a small sample, and look, the population standard deviation is not given. Equal 34. So the formula is x bar plus minus t times s over root of n. And what's the degrees of freedom? You know, v in the table,
Yeah, n minus 1, so 15 minus 1.
which is
So
14. Perfect. So if you take alpha equals 0.02, you divide by 2, it's 0.01, correct?
yeah.
So in the t-table, we want to look at 14 degrees of freedom and 0.01.
Yeah.
How much is it?
2.624.
14.
2.264,
Wow.
yeah. 2.624.
Mashallah, Fatima. And then the standard deviation is 34, square root of 15, and the mean is 80. There's a priority. You have to do this first before you can do the plus and the minus.
It should do it by itself, yeah?
I hope, but I don't
Yeah.
know if your calculator is thinking like that. I think it's answer A.
Oh, okay.
We're done with the multiple choice.
Correct.
Did you attempt to solve the long answer questions?
I did the question 1.
Did
Yeah.
you have any trouble?
No, it was easy.
Because you have two formulas for Z, right? You have to use x minus mu over sigma, or x bar minus mu over sigma over root of n.
So, yeah, there's a sample, so it's x bar.
No, Fatima, there's no sample here. The sample is here. Question B.
Random sample.
It's x between 152 and 168. And then for B, because we have a sample of n, we're going to have to use this.
Yes.
152 minus, what's the mean? 160. Standard deviation 32. You turn this into Z, and 168 minus 160 over 32.
And for that one on the bottom, it's the same. We just use x bar, yeah?
We use x bar, and then we use n equal 16.
Equals 16. Right.
And we use this formula. So the probability will be 152 minus 160 over 32 divided by square root of 16 less than Z, and 168 minus 160 over 32 over root of 16. And just to be clear, when you find, if you, let's say you get A and B, how would you find this probability?
You subtract probability of B minus probability of A.
Very good. Very good. So for A, you said the geometric mean is ln of 59.15 plus blah 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 04 over 5. No, that's y bar, and then you take the exponential of this,
Yeah.
right?
Yes.
Okay, for B, here's the data set for X. You want to find the median. I like to think of the median as the second quartile. So my question to you is, what is Q2 for X? How would you find the second quartile of this, the median?
But you can find it by the middle number, yeah?
But you have to put them in order first. Otherwise, it's not going to work.
Oh, yeah.
Promise
So,
you. So let's say we have 59.15.
72 is a 72.
Oh, no,
Oh,
68.
68.03, 72.24. 79.
24, 79.04, and then 104.58.
So the median is 72.24.
Very good. Let's look at the middle. That's Q2. But for X, he's asking you the Q2 for the linear transformation. So this is Q2 for X prime. It's 2 times the Q2 for X plus what?
3.
Plus 3. So the idea is this. If I give you y equal ax plus b, and let's say you know the Q2 for X, the question is, how do you find the Q2 for Y?
Multiply by A, add B. No, but he said find the
What's the question?
x1, x2. Why did he mention all the
What is the
numbers?
median of what?
Transport. Okay, so just give us the setup. Okay.
What is the median of the X prime data? So the median of the X prime data is 2 times the median of the X data plus B plus 3. So A median plus B, A X plus B. So let's say I give you Q3 here. This is going to be what? Q3 of Y is A times Q3 of X plus B. They gave you the variance of X. They give you the standard deviation. They give you the square of X and the sum of the squares. So basically, they give you S squared. They give you S, which is the square. Fatima, can you take the square root of this number, please? I want to see if it's equal to 26.67.
Yeah, it's 26.67. Yeah.
Okay. And then they give you the sum of Y, but Y is X squared. The sum of the value of X squared, which is 31, 25 to 17. They're asking you to find X bar. Now, the formula for X bar is supposed to be simple. You add all the numbers, you divide by the sample size. Oh, the sample is 100. That's good. Okay, so let me just write the formula for X bar just to be clear. X bar is the sum of X over N, not X squared. So he says Y equal X squared, and in the sum of Y, so that means the sum of X squared, because that's exactly what Y is. So here's the question. If I give you sum of X squared equal, let's say 10, can I say sum of X is square root of 10? Nope. Look at the cheat sheet. What is the formula that I gave you for S squared? So you have one formula that says you have to do X minus X bar squared divided by N minus 1, right?
Yeah, for the variance. Yeah.
And then you have another formula that says the sum of X squared minus N, the mean squared over N minus 1.
Oh, so you will use so you know the variances, for example,
711.34.
yeah, 711.34 equal x minus x squared.
This one is given.
So you will find the x, yeah?
You'll find the X bar by solving an equation. So this is 25 to 17 minus N is, the sample size is 100. And this is the unknown, but notice it's squared in the formula. And this is 100 minus 1, which is 99. So you have two formulas for the sample variance. And you might say, which one do I use? Depending on the question, you might use the first one or the second one. How do you solve this equation, by the way?
You multiply the 99 pi 711.34. You then subtract 3125215.
Mm-hmm.
Then divide by negative 100
Mm-hmm.
and take square root.
Take the square root. Perfect. Confidence interval for the mean.
So the sample is 6, n equals 6.
Mm-hmm. Notice it's less than 40.
And we don't have the variance.
Perfect. So we're gonna have to compute the sample. We don't even have the mean.
So we will find the mean from the question. That's fine.
Perfect. And we'll also find the variance from the question.
For the variance,
Mm-hmm.
I'll just find the standard deviation and
No, you
square
just
it.
do the usual formula, like 97 minus the mean squared plus 117 minus the mean squared plus, and you divide by 6 minus 1, and then you take the square root to get the standard deviation.
Yeah.
The mean is just 97 plus
Everything.
148 divided by 6, and that's the number that you're gonna plug here. So when you do 97 minus the mean squared plus, it's the, what is it, that formula, the first one, right?
Yeah.
Okay, so once you have x bar and you have x bar and s, what is the value of alpha?
90, so 1 minus 0.9, and then divide by 2.
Perfect. 0.05. And what's the degrees of freedom?
6 minus 1.
Perfect, which is 5. So then your formula for the confidence interval is x bar plus minus t s over root of n. We have everything. We can get t from the table.
Yeah, so find the mean, v 9 minus 1, standard deviation, variance, and then, yeah.
N equal 9, everything. Okay, boom. A certain bar is measured with a device which has a known standard deviation. Sigma is known. Suppose that we want to estimate the mean.
If you know sigma, you just use x bar plus minus z.
What is the,
Assessing normality, so
what is what?
sample size.
Sample size.
But you still use the same equation, yeah?
Huh?
You use the same equation?
I gave you the formula for the sample size. Look at the formula sheet. Sigma over this. You have something like that on your cheat sheet.
On mine, no, but I think on the cheat sheet too. We did assessing normality, but it was
This is not assessing normality. This is computing the sample size. Assume that the data has a normal distribution. What sample size is required? How do you compute the sample size?
what's the title of this?
This is confidence interval for the mean. Look at here, alpha is 0.05.
Yeah, but I haven't seen this before. I'll write it down, yeah.
And the value of z is minus 1.96 because we have 0.05 divided by 2 and blah, blah, blah. We have sigma, it's 0.5, and we have the
So what is E on the question? It's
E is the error.
always given, yeah?
Yes. So 1.96 times 0.5 divided by 0.2 squared.
24.01.
24.01.
What is it? 1.96 or negative 1.96?
It doesn't matter because you're squaring.
Okay, so 24.
You round it up always. I wrote it on the cheat sheet. Always round it up, even if it's 24.000001. That's why the answer is 25.
Yeah, clear.
Find a 95% confidence interval for the mean.
We don't have the variance, yeah? Standard deviation is 1. Oh, so we can't find the variance. So we just use x prime plus minus z times variance over square root of n, yeah?
Perfect. And we have, what is n? N is 100. 100 pieces of blah blah blah. We have x bar.
So you just plug everything.
We just plug everything. 95%, that means z is what? Minus 1.96. Okay.
Yeah.
So that's simple. What is the difference between this question and?
Oh, so the number of pieces. So you use a t-table because it's
Very good.
less than.
Mashallah, Fatima. you use the t-table. Okay. Okay, I think we did this before. So normal distribution